Game of rock, paper, scissors is a fairly common parlor game. And the idea is that two players make a choice of rock, paper, scissors, and they show that to each other at the same time. And so if I show a rock and someone shows paper, paper covers rock. If someone else shows paper and I show scissors, scissors cuts paper, and finally rock smashes scissors. We can actually represent that as a normal form game, where using our definition of a normal form game, we have n equals 2 players. The action sets are A1 and A2, and the fact that there's 2 is because there's 2 players. Every player has an action set, and they are rock, paper, and scissors. So rock, paper, scissors are the actions everyone can choose. And the outcomes of the choices of the cross products of A1 and A2 correspond to the little story I just said, which is that rock beats paper, paper beats rock, rock beats scissors, and scissors beats paper. And we can represent that as a normal form game where we can say, okay, matrix A is going to be equal to 0, -1, 1, 1, 0, -1, and -1, 1, 0. Let me tidy up that 0 ever so slightly. There we go. And so what we have there is that the first row and the first column correspond to rock, the second row and the second column correspond to paper, and the third row and the third column correspond to scissors. So first of all, you see in the diagonal, you have the ties. So if I choose rock and the other player chooses rock, it's a tie. If I choose paper, the other player chooses paper, it's a tie. And likewise, if we both choose scissors. Now, if I choose rock and the other person chooses paper, we see the entry of the matrix A is -1 because I lose. And if I choose rock and the other person chooses scissors, we see the entry of the matrix is a 1. And the other entries follow. And as I mentioned, this is a zero-sum game. So if A equals -B, because if I win, the other person loses, and vice versa. Now, if we have 2 players, and let's say that these 2 players are playing a particular strategy where the first player is just always paper. Okay, rightly or wrongly, they're just always picking paper. Let me just move this slightly. And the second player is 50% of the time they are going for rock, and 50% of the time they are going for paper. So one person is just always picking paper, and the other person is completely randomly selecting between rock and paper. What would the expected outcomes be? And so what we can do is we can say, okay, well, what this is saying is that we're always in the first row. And what this is saying is that 50% of the time we're in the first column and 50% of the time we're in the second column. So 50% of the time the row player is getting 0, and 50% of the time they're getting 1. So the expected score of the row player, would be -1/2. And because the game is zero-sum, let me just move that over a little bit. Because the game is zero-sum, the expected payoff of the column player would be 1/2. Right? Those are the outcomes. We can do it just because we know that it's zero-sum, so whatever we have an expectation here, we get -1, or we could actually look at the value of the matrix B and just get the opposite numbers. But what I'm particularly interested in here is, that was a bit fast. What I'm particularly interested in here are these things. Rules that describe how players, how individuals choose from their action sets is what is called a strategy. So a strategy allows us to select from our action sets in a particular way. And that's what the next set of videos is going to be about.